In this class, we shall solve multiple choice questions. Multiple choice questions. So, problem 1. 5 moles of an ideal gas at 27 degrees centigrade expands isothermally, expands isothermally and reversibly from a volume of from a volume of 6 liters to 60 liters. The work done in kilojoules is the work done in kilojoules is option A negative 14.7, B negative 28.72, C positive 28.72, and option D negative 56.72. So here we need to mention the sign of the work also. What is that? If the system is doing the work, that is negative side, and work is done on the system, then the sign is positive. So we should find out that also. So the direction of the work. Okay. So what is the crucial point here? We need to find out what kind of equation we are going to use in this problem. It says it is an isothermal expansion, and most importantly, the crucial word here is reversible expansion. Therefore, what is the equation for the work in isothermal reversible expansion is work is equal to negative 2.303 nRT log V2 divided by V1. And the problem says the temperature is 27 degrees centigrade, which is equal to 27 plus 273. To convert this into Kelvin, that gives us 300 Kelvin. And depending on the units in the problem, the final reporting unit of the work is joules. Therefore, R value must be used as 8.314 joules over mole Kelvin. And how many moles of the gas is there in the problem? There are actually 5 moles in the problem. So therefore, we should take n equal to 5 moles, and V2, the final volume is 60 liters and the initial volume is 6 liters. Now let's substitute all these parameters in the expression of work, that is W is equal to negative 2.303 times, what is the N? N is 5 moles, times what is R? 8.314 joules over mole Kelvin, times what is the temperature? 300 Kelvin, times log 60 liters divided by 6. So liters will cancel out, and we get 6 1 ja 6 10 ja. So log 10 is there, and log 10 value is 1. And here the mole and mole cancels out, Kelvin and Kelvin cancels out. And finally, we end up with unit joules, which is the unit of work. So this negative sign indicates work done by the system, which is expansion. So therefore, answer must have a negative sign. So from that, we can easily eliminate option C and option D. So our answer is only between A and B. Let's find out the answer, whether it is A or B, by doing the mathematics. So what is the mathematics here? Let's do the mathematics. I am taking help of my calculator. 2.303 times 5 times 8.314 times 300. So I got work value as negative 28,720.7 joules. So do we have that number in the answers? No. We have very simple numbers 14.7 and 28.72. But actually we have to report our answer in kilojoules. But we have here our answer in joules. Therefore, we must convert that into kilojoules. How? 28,720.7 joules. And we know 1 joule is equal to, sorry, 1000 joules equal to 1 kilojoules. So that gives us 28.7207 kilojoules, which is minus sign. So this is our answer for the work done in the expansion of 5 moles of gas from 6 liters to 60 liters at 27 degrees centigrade. The amount of work done is 28.72 kilojoules of work done. Therefore, our answer is clearly B. Okay. Now, let's go to the next problem. So, what is the problem here? That is 10 moles of an ideal gas. 10 moles of an ideal gas confined to a volume 10 liters is released into atmosphere at 300 Kelvin. Where the pressure is 1 bar. Where the pressure is 1 bar. So not atmosphere, bar unit is given here. The work done by the gas is, so we need to find out work done by the gas. Work done by the gas is, okay, what is the option A? That is 249 liter bar. Instead of liter atmospheres, the unit of work it is liter atmospheres. And B, 259 liter bar. C, 239 liter bar. And D, 220 liter bar. This is the problem. And what is the R value? R value is not 0.0821. Instead, we have to use another R value. R value when we have a pressure in bars is 0.083 liter bar over Kelvin mole. This is the unit of R value in liter bar over mole Kelvin. Okay, so this is a gas expanding from 10 liters into atmosphere at 300 Kelvin. So what we need to find out? Work done by the gas. Okay, we need to find out what is the expression for the work. Expression for the work is P delta V. Okay, so basically we use negative P delta V, and here there is no answer in the negative signs. So therefore, work done by the gas, obviously it is negative only, but we don't need to report it in the negative values. So therefore, that's going to be negative P. What is the P here? External pressure is 1 bar times delta V. To know delta V, we must know initial value and we must know final value. So in the problem, anywhere, do we have initial and final values? Yes, there is initial value 10 liters, but it seems there is no final value in the problem, and that needs to be find out. So let's take V1 is equal to 10 liters. And what is the V2? We don't know, we need to find out. Once we know the V2, we can easily find out W. So what is the formula for ideal gas? PV equal to N0. So the gas is expanding, okay, into the atmospheres. So let's substitute V equal to nRT over. So how many moles of gas is there in the problem? 10 moles of gas is there. R is 0.083. And what is the temperature? The temperature is 27 degrees centigrade. So sorry, not 27, it is 300 Kelvin. So therefore, let's substitute here 300 Kelvin divided by, and what is the pressure? 1 bar. Okay. After expansion, that volume is going to be final value. So therefore, V2 is now going to be, how much we get V2 now? Again, mathematics help, 10 times 0.083 times 300. So I got 249 liters. So now let's substitute here V2 249 liters minus V1 10 liters. So that gives us a negative 249 minus 10 is 239. So negative 239 liter bar. So that is the answer here. So the negative sign indicates work done by the gas. Therefore, we don't need to include the negative sign in the answer. So if we observe the options A, B, C, D, our answer is matching with C. Therefore, answer for the problem 2 is C. So third problem. What is the third problem? That is very simple problem. This is 1 liter atmosphere work. 1 liter atmosphere work is approximately equal to. So this is purely memorization. Approximately equal to A 101.3 joules, B 8.314 joules, C 931 joules, and D 19.2 joules. So what is the answer? Answer is clearly 101.3. So how do we do that? 1 liter atmosphere is equal to 101.3 joules. What is the unit of joules? Joule is equal to Newton meter. And this liter atmosphere we must express in Newton meter. How do we do that? So here we need to do a kind of conversion. Let's find out. So this is, I can express this one as 1 liter, I can express as decimeter cube. So 1 liter equal to 1 decimeter cube, and atmosphere is basically 760 mm. So if we convert that into Newton per meter square, basically pressure unit is. So atmosphere. So we don't require that much big length here. So we can stop here. The answer is simply 101.3. Okay, now let's go for the problem 4. Problem 4 is, when a system absorbs 20 kilojoules heat and also does 10 kilojoules of work, the net internal energy of the system. So this is the problem A. Increases by 10 kilojoules. Increases by 10 kilojoules. B. Decreases by 10 kilojoules. C. Increases by 30 kilojoules. And D. Decreases by 30 kilojoules. So now let's find out what is the answer here. So delta E is equal to Q plus W, which is first law of thermodynamics to equate internal energy changes, work done, and heat changes. Therefore, here, what is a delta E? That's what we need to find out. Delta E is equal to Q, heat. It says the problem in what is that? System is absorbing the heat, therefore it must be a positive side. So 20 kilojoules, and it is doing the work. It is absorbing 20 kilojoules of heat and also does 10 kilojoules of heat. Therefore, that must be a negative. So 20 kilojoules minus 10 kilojoules is 10 kilojoules, which is positive number. That means internal energy of the system increases by 10 kilojoules. Why? It is absorbing 20 kilojoules and only spending the 10 kilojoules as work. The remaining 10 kilojoules are resulting in the increase of internal energy. Basically, that will be reflected in the increase of temperature, because internal energy depends only on the temperature. If internal energy increases, temperature increases. If internal energy decreases, temperature decreases. So that's the answer. Now let's go to another problem. This is problem 5. 1 mole of a gas is heated. 1 mole of a gas is heated at constant pressure but to raise its temperature by 1 degree, temperature by 1 degree centigrade. The work done in joules is the work done in joules is okay. Now let's find out what are answer. Before we find the answer, let's take the options. A is negative 4.3 and the unit is joules. B is negative 8.314. C is negative 16.62, and option D is unpredictable. We can't say. It can be any number. So that's what the meaning of unpredictable. So let's find out what is the work done. So for gas, PV equal to nRT. So at constant pressure, therefore change in volume is resulting in change in temperature. Therefore we get P delta V is equal to nR delta T. Therefore work is equal to negative P external delta V. That's going to be replaced with negative. What is the P delta V is nR delta T. So let's substitute here. So here what is the N? 1 mole. And what is R value? R value is very important. That is 8.314 joules. And what is the delta T? Very important point here. Looks there is no initial temperature and there is no final temperature, but it's a very important word. What is that? Raising the temperature of the system by 1 degree centigrade. So initially some temperature is there and final temperature is just 1 degree above the initial temperature. That means change in temperature is only 1 degree. So if we substitute here, even in the Kelvin also, the difference between the two successive numbers is 1. So 273 centigrade, 274 centigrade. Even if we convert them into Kelvins, the difference will be always 1 only. So therefore here we get negative 8.314 joules as the answer. Therefore what is the answer here? Negative 4.3, negative 8.314, negative 16.62 and unpredictable. So therefore our answer matches with option B. So that's the answer. So in this problem, to raise a 1 gram of the 1 mole of the gas temperature by 1 degree centigrade, and the amount of heat required is 8.314 joules at constant pressure. That is important word. So next, let's go to the next problem. The problem is sixth problem. In an open system, so this is the problem based on the very first class problem. Option A, there will be exchange of both matter and energy. Option B, there will be no exchange of matter and energy. Option C, there will be exchange of energy only. And final option D, there will be exchange of matter only. Okay, so we discussed in the first class, systems are classified into three categories depending on the kind of transactions with respect to heat and matter between system and surroundings. If the system and surroundings are able to exchange both matter and energy, that system is known as an open system. Any system that only exchanges heat with its surroundings but doesn't allow any kind of matter exchanges, that system is known as a closed system. There will be another kind of system which doesn't allow anything, even in terms of matter or in energy matter, heat matter. That system is known as a isolated system. No exchange of energy, no exchange of matter. That system is known as a isolated system. So here in this problem, it is about open system. Therefore, that system will be able to exchange matter and energy. Out of these four options, A, B, C, D, the option A says there will be exchange of both matter and energy, which is the main character of open system. Therefore, the answer is A. So this is the answer for problem 6. Now let's do one more problem before we end the class. So that is, okay, the last problem of the class. Calculate Q, heat, W, work, delta E and delta H for the reversible isothermal expansion of an ideal gas at 127 degrees centigrade from a volume of 10 decimeter cube to 20 decimeter cube. Okay, let's do this problem. It says that the expansion happened in isothermal condition. So isothermal condition, so very critical word. This word indicates the process is a constant temperature process. Okay, and we know that enthalpy and internal energy both are only functions of temperature, and we have proved this in a special class exclusively, which says internal energy and enthalpy are only temperature dependent. They don't depend on pressure and value. So as this process is constant temperature process, there will be no changes in internal energy and enthalpy. So that clearly indicates change in internal energy delta E is equal to 0, and change in enthalpy delta H is also 0. And here one more thing, work and heat are not zero here. In the uh, isothermal process, heat will be absorbed or heat will be released, and work is done by the system or work done on the system. There will be something happening in terms of work and heat, but nothing is going to happen in internal energy. System simply acts as a medium between work and heat. So let's find out work and heat. So therefore, the work done expression for isothermal expansion is W equal to negative 2.303 nRT log V2 by V1. Okay, and here how many moles of the gas is given? Uh, Reversible isothermal expansion of ideal gas at 127 degrees centigrade. Okay, so there was no word mentioning regarding the moles of the gas. So okay, let's take for 1 mole of gas. Let's take N equal to 1 mole, and the temperature is 127 centigrade. That will be in Kelvin is 400 Kelvin, and V2 is 20 decimeter cube, which is basically 20 liters. V1 is 10 decimeter cube, which is 10 liters. Now let's substitute. So now when we substitute here, let's try to substitute the R value in joules, because that is the most standard unit of work. So W is equal to negative 2.303 times 1 times 8.314 times 400 times log 20 liters divided by 10 liters. Log of 20 divided by 10 is log 2. So here we need to do the maths. Let's do the maths. So let me use my calculator to find out the 2.303 times 8.314 times 400 times log 2. So I got this one as negative 2305.3 joules. This is the work done by the gas. So that work done by the gas, that clearly a indication from the negative side. So this is the work done. Okay, so we need to find out the work. Work is going to be negative 2305 by the gas. Now what is the heat Q? Let's find out. Let's use delta E equal to Q plus W, which is first law of thermodynamics. So that says delta E value must be substituted here. So what we learned in the very beginning of the problem, there is no temperature change, therefore there will be no change in the internal energy of the gas. Therefore that is 0 equal to Q plus W. So from this, the heat will be is equal to negative W, that will be equal to negative, and what we got the work, negative 2305.3 joules. That gives heat equal to 2305.3 joules, which is positive. System is absorbing 2305.3 joules of energy and undergoing expansion, which is equivalent to a work of 2305 joules. Wonderful. 2305.3 joules of heat is absorbed, and that heat resulted in 2305.3 joules of work. Very great thing. But do we really have such systems where they simply take the heat and give us the work in the same quantity. So such kind of systems are ideal systems, and it's very very difficult to produce or build such kind of systems. So that is the limitations of first law. So there is no such heat engine where it can take the heat and simply convert that into work. There will be some losses. So that is the uh, problem with the uh, heat engines. So we don't have heat engines with 100% efficiency. So we will study that in the second law of thermodynamics, and there also we have Carnot cycles. So efficiency of engine, and there will be introduction of new parameter in the thermodynamics, which is bit confusing but very interesting uh, parameter or variable thermodynamic uh, uh, property, that is entropy, and we will study that when the second law of thermodynamics comes, which talks about spontaneity of the system. Okay, this is for the today's class. Thank you very much.